Hi, thank you, Ren. Hi, everyone. I'm Martin. I come from the Shopee Data Infra OLAP team, and today I will share the StarRocks architecture for the Lakehouse and the local storage, and focus on the high performance and high availability. So before I started, I will share some background information about Shopee and why we choose StarRocks. Shopee is the biggest e-commerce platform in the Southeast Asia, and we have hundreds of millions of user products, which means we have a lot of data. And our business is data-driven business. We analytic data to do the recommendation, search, and operations. And so the with the Shopee business grows up, we have more and more requirement for the analytics. The latency requirement is high, the write latency, no matter write latency and query latency. And before we using StarRocks, we already have a several OLAP engine like ClickHouse, Street, Presto, and they did well, but StarRocks has its special part. StarRocks can support the high concurrency with low latency. And especially StarRocks supported the Lakehouse and the log storage view, which means it can meet our high performance requirement and also can save the storage cost. And because of StarRocks has this kind of the ability, it also can give us more possibility for deploying our own architecture to support the Shopee's massive business growth. So I will share today's topic through the three specification, from three aspects. So firstly, I will share the Shopee StarRocks currently our cluster specification. We provide the two kind of product. So one is a computing queue, the other is storage cluster. Then I will dive into these two to share some technical environment and some pinpoint. And most importantly, I will share the business use cases. So the first part is Shopee StarRocks cluster specification. First cluster specification is the computing queue. The computing queue is a resource specification we provide to the users. It's a logical layer. So it can be bounded to one or more computing clusters. Computing cluster is StarRocks clusters. Why we call this computing cluster? The important thing is the B node will not store data themselves. So the only query data is stored in the remote storage, and that storage is data managed by the Hive store. So this is computing cluster. And the queue, the computing queue can be either small or large. A small queue shares one cluster. A large queue can span multiple clusters. Like the left, this one, this is a large queue. So this large queue has three shares, spans the three cluster A, B, C. And the right part is a small queue. We can see the three queue shares one cluster. And each queue's resource isolation, we use the StarRocks resource group. Why we design like this? Because based on our Shopee Live usage experience, one storage cluster speed node even extend 200, it will facing some the query stability issue. So we design like this one, because some queue could be very large because it require a lot of resource. And the storage cluster actually the traditional StarRocks cluster as a B node will store data. Of course, this storage cluster will also support the query external catalog. We also support the query X catalog, which is the metadata in the HMS. So the storage cluster also can query the Hive, Hoodie, payment, this kind of thing, Lakehouse. And the most important is our storage cluster supported the disaster recovery across multiple IDCs. So later I will share more detail about this. Then let's dive into the computing queue. So for the computing queue, as I mentioned, we are computing queue. So the queue is a logical layer. User will access the queue. And why we design like this? Because this design is almost similar with our Trino. When we involve the StarRocks computing queue, we want to let the user convert transparently. User will not need to convert their SQL. Even some users don't know the engine changed. So the first important thing, we are fully compatible with the Trino SQL dialog. So at the beginning, based on our rollout test, only the 40% Trino SQL can be dispatched to the StarRocks. And then we upgraded the StarRocks version to the 3.3. And at that time, StarRocks supported the unified catalog, which means we can use the one catalog to query Hoodie and Hive. And also at that version, the StarRocks support query Hive view. And at that time, the compatibility reach to the 16%. Then we also do some of the functional compatibility, like the data trunk to Unix time from Unix time, and we also support the queries ozone table using the S3 protocol, and support the aggregation with a filter. And nowadays, our StarRocks can the Trino dialog computing reach to the 85%, which means the 85% users query can dispatch to the StarRocks. And the other thing is the stability, because we involve more and more users to using StarRocks, and we don't want the user feel instability or feel some issues. So stability is very important. We also do some development and evaluation. The most important thing is we do the logical queue abstraction. Why we do this? Because this logic queue can be rebounded to healthy cluster dynamically when fail over a course. So sometimes the physical cluster we are facing some issues. We cannot avoid the kernel is not bug. Sometimes it will have the OM issue or have the hang issue, and sometimes the physical machine will down. So we can rebound the queue to the healthy clusters, and because of this, it also can support the computing queue the disaster recovery ability and SLA protection. So this evaluation step we called from the single cluster bounding to cross cluster scheduling. Or like this. The user access is computing QA, and when the cluster physical cluster 001 has done some issue, it has done, we will scheduling the QA to the another cluster like here, and this queue shared in the cluster 001 QB we are also scheduling to the other clusters. And for the computing queue, we also identify some of the pinpoints. The most important, I think the really pinpoint issue is the hidden but critical issues. The syntax cannot compatible with Trino is not important, and facing some query has some exception is also not important, because when the user start send this SQL, it already facing the issue. The critical issue is the query can execute it well and also can get a result, but the result is mismatched with the Trino, and only we can know it when we compare it to Trino. Why this is very critical? Because as I said, we don't want the user to feel we change the we change the OLAP engine. So the user, they have their own script, they have their own SQL, and if we let these users query execute in the StarRocks and get the wrong result, some business BI teams they also do some report which is related about the financial. So this maybe caused some financial loss. So it's very critical issue. And I made some example about something can cause this issue. First one is metadata cache. The StarRocks query the external catalog has a very good performance because of this, and also because of the metadata cache. Sometimes the result will be different with the Trino. That's because of when the StarRocks query the Hive table is firstly it will query the metadata cache, the table metadata, partition metadata, and the remote field metadata, and Hive will directly fetch data. So which means if the user ingests some data to the Hive and the metadata is not refreshed, the result will be different. So this is StarRocks metadata cache introduction. StarRocks metadata, we can see it have a lot of metadata cache, and generally it has three things: table metadata cache, partition metadata cache, and remote file metadata cache. And we do some our own strategy. For the Hive table, it has a managed table, external table, and virtual view. For the managed table, we set the strategy is we remove the cache for the partition names. We set the remote file TTL 2 minutes and do not refresh. So every 2 minutes, the cache will expire. And for the external table, we implemented our own logic that to achieve the external table can be refreshed. This feature will also can contribute to the community. And for the virtual view, we implemented a logic that will always get the latest Hive view. The Hive views select logic will analyze table. So after we adapt this strategy and our feature, this kind of issue can be solved. The other things can cause this issue is some operator behavior difference. This operator behavior difference, I'm not to say the StarRocks gets the wrong result because it just has a different behavior. I make the example using the join using. So join using behavior is differently in StarRocks and Trino. The schema alignment and output column did not match. We are leading the downstream ETL failure. So what's the difference between the Trino and StarRocks? We can have the example in here. This is a very simple SQL. And in this one thing, we can see they have a CTE A and B, and both they have a PK column. And for the Trino, they will duplicate the column. So they get the result pick only one column, PK, and the result is 1. StarRocks will have 2. And for solve this kind of this issue, normally our solution is we refine the operator semantics to align with Trino. We implemented the field deduplication mechanism. We're removing the using column from left-right table field list during the join analytics. And that's for the technical environment. And and also our computing queue, the business is grows very fast. We started to roll out the computing queue in the last September. So last September, we only have 500 code during the double run. Double run means this resource is not on level environment. So doing some test, the query will dispatch to the StarRocks, and also query will dispatch to the Trino and compare result and compare performance. And on the October 24, we already have 800 core resource. And on this year, end of last year, we already have 12,000 core. And until the last month, we already have 22,000 core resource on our business. So we grow very fast. And notice our main use cases for the computing queue is 2. One is for the BI users. They do some ad hoc queries and BI analytics, and for generate some reports. If you see clearly, you can see here, this platform we built, the language is Presto SQL. So user actually, they didn't convert the SQL. They still write the Trino SQL and get the better performance and reduce some cost. And the other use case is the dashboard. This one is not published yet. We're still doing the integrating because this diagram, this diagram is based on the query the have table and get the data, and based on that data, we draw the diagram. And the dashboard business is this business. Their query pattern is more is less complex than the ad hoc query. So we think that for the dashboard, we can support the even much more better complexity, dialog complexity, and much more better performance. And the third part is our StarRocks storage cluster. So the storage cluster, the first thing I want to share is our cluster is a high ability architecture. So how we achieve this high ability? First of all is we provide our users dedicated clusters. So dedicated cluster means each business run its own storage cluster. So the resource is totally a solution, no performance interference across the business. And the other one is we support the disaster recovery. And our disaster recovery is a table-level disaster recovery. That's because of some of the StarRocks instance database. They have more than 1,000 data tables, but not all the tables are critical. For example, some users maybe have 1,000 tables, but only 100 tables is critical. This tables dashboard or this tables platform is very important for the business. So they can only to configure DR for these tables. So they can reduce, save some money, save some cost. And this is the architecture about our dedicated cluster and disaster recovery. So the user will access through the HA domain, and in the normal condition, it will route to the main cluster. And if facing the main cluster facing some issues, so we will switch the DNS, and we will reconfigure the DNS to let it route to the DR cluster. If you notice, actually, I put the 2 access layer. First access layer is actually domain, and the second access layer is here. That's because of the cluster down is not very common things. So if user configure the DR cluster and not never use that, it's kind of the resource based. So user can also access through this layer. He can using the main cluster as a red cluster and using the DR cluster as a read cluster. So it can also achieve the read-write segregation scenario. And the data sync, we using the communities sync tool. We incubated the sync tool and doing some our own self features to achieve this one, to achieve the DR ability. So for achieve this architecture, the most important thing is our cluster deployed in the Kubernetes. So all cluster runs in the container environment, which enable we can faster bootstrapping and migration without physical machine constraints. And also we integrate with Argo City API. We deliver a visual one-click and a white screen operation platform. So using this platform, we can manage a lot of the dedicated clusters. So nowadays, we already have more than 45 dedicated clusters. And the other important thing is we build our own sync tool based on the community's sync tool. We encapsulate the sync tool and also add some logic for the dynamic config rendering. And we deploy the sync tool as Kubernetes deployment pod, so which can allow us to enable and disable on demand. And we also build the white screen UI to allow the business user to configure which table and database to need to do the synchronize. So we can see here, this one is our operation platform. Now it allows us to manage the multiple dedicated cluster. You can see we have BE managed, we have a queue managed, we have clusters. So based on this one, we can support the dedicated cluster to users. And this website is user managed. Is for users. User can manage their dedicated cluster through this website. You can see here, user can configure DR. User can configure DR by choose one table or choose a multiple table. And that's all for the technical issues. And now I will share some of the business scenario for the storage cluster. Nowadays in the Shopee, we mainly have three business scenario. One is real-time business monitoring, and the other one is data warehouse, and the last one is analytics acceleration and experimental. So I will give some example from these three scenarios. First one is from our paid ads revenue loss platform. The paid ads revenue loss platform is for observe the advertisements GMV, advertisements click, UV, and its ROI conversion rate. And this platform, because the marketing team, advertising team, will based on these metrics to do the analysis whether this advertisement can really earn money or save the budget. So the HLA and the real-time requirement is very high. So this platform actually has seven dedicated cluster. Because Shopee's business has a lot of region. We have Malaysia region, Singapore region, Brazil region, Taiwan region. So each region will have its own cluster. So it ensures the isolation and stability. And here is the revenue platform overview. I hid many data, but we still can see this is a shop advertisement. So it's a budget, GMV, and clicks. So the marketing team and the advertising team will using this platform to do the analytics. And because they need to do the analytics and which is related about the financial and the budget, so the data accuracy is very important. So user using the Flink connector and using the exactly once transactional rights, it is very important, and it is also a very special part for the AP database. Most AP database cannot support the transactional rights. And because of advertisement comes from our platform, so the data is very large. So if users see all the detailed data, the table will become very large, and the query performance also will be affected. So user only sees the aggregated data. So they using the StarRocks aggregated tables. It can save the reduced storage usage. Also can make the query performance much more faster. So nowadays the performance achievement, the write latency can achieve the minutes level, and their query latency is a millisecond level. And during their seven dedicated cluster, the largest cluster nowadays is dozens terabyte. And the other scenario is about the warehouse. The warehouse is a Shopee Pay reconciliation platform. Shopee Pay is one of our product in the Shopee. It supports the online payment, fund transfer, and some other financial services. And because of the rapid growth of users and the transaction volumes, they need to build a reconciliation platform to ensure the transaction is accuracy. So they have the original pipeline is using Flink to compute metrics on demand, and then write to the DWS table, and queried by the MySQL. The advertisement for this pipeline is real-time processing, fast query speed. But the disadvantage is this is limited flexibility because all the metrics was needed to be deployed, implemented using the Flink SQL or Flink code. And because they queried using the MySQL, so it cannot the accumulation of the data set. And also it has redundant functions and codes, resource-based. So they do the upgrade. There is a new pipeline. The new pipeline using Shopee are using StarRocks and Pyman to achieve the data warehouse pipeline. So the raw data is in the MySQL, and the ingestion so the Kafka will use ingestion so the MySQL being logged to Kafka, and the Flink will consume the Kafka data to insert to the Pyman, and the Pyman will ODS or DWM and the DWS, and StarRocks will query payment table. For some critical DWS table, they will use the material view to make the query performance much more better, and this is their platform. So the overview for the new solution: the detailed data will ingest in real time to the Pyman data lake, and the Flink can build the white table in Pyman, so they can accumulate a data warehouse. And StarRocks will query the Pyman white table and gives a very fast, immediately result. And real-time data ingestion build a real-time data warehouse, so it avoids the ad hoc metric development. And also it integrates with Pyman, ensure the data is up to date and consistent. So this is a Shopee Pay business. The last one scenario is a Shopee A/B test platform. So this A/B test platform is for doing some of the business decision. So this business decision includes the layout optimization. The layout optimization can be the home page or web page, and also some of the recommendation algorithm updates. So their goal is evaluate the impact of decisions using the small-scale random experiment, and they're using the overlapping experiment to allow the traffic reuse with the stratification. So this is their workflow. So the business team will register the data sets through the Hive to OLAP entry and define their required metrics. Their metrics can be the region, data group, or some customer queried dimensions. And the StarRocks rule in this platform is StarRocks will directly query the Hive table or its own table. And also StarRocks will compute metrics efficiently for experimentals and supported the multi-dimensional aggregation for the quick analysis. Here is the workflow. We can see the raw data is the Hive table, and they using the Hive table register the data set. So they can build the StarRocks table, and the data set will be the StarRocks table. And they also can using the external catalog. The data set will be StarRocks query the Hive table, and they also can build the customer query. The customer query can StarRocks query Hive table, join the StarRocks inner table, and generate the data set. So this is some of the example metrics. The metrics A, B, C, and the logic we are using the SQL logic to the sum aggregation. So in this business, the StarRocks can directly query the internal table. When the StarRocks queries the internal table, the performance is very good. So it provides the second level query latency. And also, StarRocks can query Hive table directly, which allow user can save the storage cost. For some user teams, they have a limited budget, so they can use this way. And also they can avoid the data deduplication because they no need to copy data from Hive to the StarRocks. So the key benefit for this workflow is give the user flexible choice between the high performance internal table and the cost efficiency Hive queries. And also it ensures the scalability and meets the multi-dimensional analytics. That's all for my share. If you have any questions, can tell me. Thank you everyone. Thank you.